This is page 15, number 27. I have the illustration already drawn according to the description of the problem. The area of the region stays fixed at 1,000 square feet. This length of the wall, at most, is 100 feet. So we are looking for the limited, or the minimum rather, amount of length required to fence in these three sides, given that this area stays fixed at 1,000 square feet. So my formula for the area is x times y equals 1,000 square feet. And they're using capital L to represent the length of these three sides, which is x plus 2y. So that's part A. Part B is says to express the length as a function of x. Well, by substitution, this is 1,000 divided by x, and then plugging back in down here, we get x plus 2,000 divided by x. And this is the equation that we want to put into the graphing calculator. So on our horizontal axis, x is going to represent this length. On your calculator, it'll have y as a function of x, but y on your calculator really represents capital L. And we are looking for the minimum value of this function. We get a rough sketch, a rough curve that looks something like this. And when you go through, after you have entered this into your calculator and gone through the commands, you're going to get a minimum x value of approximately 44.772. And then by substitution, the y value is approximately 22.36. And then subbing into this formula here, we get a minimum length value of roughly 89.442. So when you put in this equation into your calculator and you go through, you'll need to set your window. All right? Your window could range from 0, your x value, 0 to roughly 100. Maybe do a scale of 10. And then for the y on your graphing calculator, which is representing L, something to the effect of 0 to maybe 100 on a scale of 10. And when you go through and do the commands, you want to look at second trace or second calculate. And you want to find the key that says the minimum value. And you want to zoom in on that minimum value for x, which is approximately this value right there. I hope that helps. See you real soon.